Welcome all. This is Sanmitra Dharmavarpu, finally a computer science student from Welfare Institute of Science, Technology and Management. I'm here to share my final year project. The project name is Image Caption Generation using CNN RNN model and using it to increase web accessibility. This is my team, Sanmitra, myself, and the other team members are Teja Ratnakumari, Sai Kumar, Rohit Kalki, and Padmini Ramani. Our project guide is K.V. Kiran, Associate Professor at Welfare Institute of Science, Technology and Management. Going into the details, image captioning task is one of the important tasks of AI, and a lot of research is done so far in this field. One of the biggest advantages of this is it can help a lot of visually impaired people on the globe to know what is exactly happening in an image. So we thought of using this advantage to help a lot of people on the globe, and knowing the contents of an image is one of the important important objectives of web accessibility. We created a CNN RNN model using the techniques from state-of-art research that is done so far in this field. To help a lot of people to reach this, we created a web interface, an API, and a Chrome extension, so to automate the process of adding captions to an image. We thought with this we can help a lot of people on the globe, and we can also increase accessibility in the web. Introduction, as I already mentioned, so far concept of adding captions to an image on the web is done manually by the web developers, but using the advantages from the research in image captioning and artificial intelligence, we can automate this process. There are a lot of researchers working very hard to get a better results, and they are making a lot of things which are thought to be impossible and making them possible. One of the things is image captioning. We thought of using that research to help visually impaired people to know what is exactly in an image. This is not only constrained to web accessibility, this can also be scaled to other types of applications. For example, using our method, anyone can create an Android application that can read what is happening around it through the camera, and it can generate captions by capturing the image from the camera, and we can pass it on to the blind person so that he can know, after generating the caption, so that he can know what is exactly happening around him. This is so. On the other hand, we can also increase web accessibility. Web accessibility is nothing but, this is the one which is taken from W3 Consortium website. As you can see, web is fundamentally designed to work for all people, whatever their hardware, software, language, location, or ability. When the web meets this goal, it is accessible to people with diverse range of hearing, movement, sight, and cognitive ability. One of the major goals of this website, web accessibility, is it asks the developers to add alternative text to every image whenever a web developer uses an image on a web page. One of the constraints it fixed is every image should have a an alternative text, so that that can be used by text readers like Chromebox, which will be used by visually impaired people to stream the web. So every one, every developer works really hard to add exact caption to that image. One of the problems, I cannot say it as a problem, but one of the hardest tasks is we cannot write simply the file name or anything. The main goal of this is, for example, if at all an image which contains a horse drinking water, the alternate text should be there is a horse which is drinking water, in that way. The motivation for this project is started in my second year of graduation, where I learned about this web accessibility in my Google India Challenge Scholarship Mobile Web Specialist Nano degree, where they stressed on this web accessibility, and they showcased a lot of case studies where people use who are visually impaired. And one of the main rules they taught to me is that whenever I develop any kind of website, I should not miss alternative text for that. Then I thought, well, because of increasing generation of a lot of images on every day, as we all know, we are in the data age, and every day a lot of images are being generated continuously. So if at all I can automate this process, a lot of people who are visually impaired can have a better experience of web. For example, if at all if you consider any social media platform or any platform where the users will upload an image, if he is not a web developer and he doesn't know what is web accessibility and how it is useful to all the people, he may not give some alternative text for that, so that it may hurt some people who uses the web. So if at all it is not present, we thought we can automate that task up to some extent to increase the web accessibility and to have a better experience for a lot of people who are visually impaired on the globe. There are a lot of advantages to this web accessibility. The top 5 advantages we got from the wholebraingroup.com is it avoids discrimination and legal complications, because the discriminations is it works only for the people. For example, if the website does not have any or does not have alternative text for any image, it is considered as a discrimination that that website is only designed for the people who are visually good. So it does not feel good for the person who is visually impaired. Such kind of discriminations can be avoided, and builds positive public relations. It also helps better search engine optimization, so that your page rank will be in a better place. It improves the usability of all types of visitors who are of having any type of disability, and it also broadens your market penetration. So there are a lot of advantages of increasing web accessibility, both in a social way, social responsibility way, and also in an economic way. The existing system currently, there are systems which are working really good, like Google Lens and Vivo Zoe, which are capable of detecting objects in an image. These are widely used, but there are no widely used applications to explain what is exactly happening in an image. There are no widely used applications to explain the scene of an image. Coming to the web, all the web developers, whenever they are creating a web page or they are uploading an image, they are manually adding alternative text to that image. So the proposed system is We created a CNN RNN model. This will mainly have two neural networks. The first one is convolution neural network. The second one is recurrent neural network. CNN is used to extract features from an image. It extracts features from a given image and represents in a format that is small and very much useful. Coming to the RNN, this RNN will take that feature information or feature vector from the CNN as an input and generates captions to that image in a human spoken language. On a whole, it takes an image as an input and provides caption as an output. We created an API to make it available to web developers to automate the task of adding captions to an image. We also created a Chrome extension so that whenever a visually impaired person who wants only, for example, no, if some of the websites does not use any kind of websites, any kind of APIs like us, there may be chances of not having an alternative text. So to help such kind of people, we created a Chrome extension which automatically adds captions to the image where it does where they don't have any alternative text. So the system requirements, software requirements. We use PyTorch as our deep learning framework. We completely use this for not only for convolution neural network. We did all the work in PyTorch, and we used OpenCV for working with images. We used Miniconda for having custom environments. Hardware requirements, obviously we use MS Coco dataset, which is around 25 GB of data. To handle such large data, we definitely require state-of-art GPUs, but we restricted ourselves to the resources we have, which seriously impacted our models predictions. And we used SSD for storing the images to reduce the, at least to get a better speed of reading data from the disk. We used i7 processor to achieve a better speed. Going into the technical details. First one is model architecture and construction. This is our CNN RNN model. Here you can see the first one in this is a CNN, which is nothing but a convolution neural network, and this is an RNN, and the whole image is an unbounded version, or we placed different iterations of LSTMs or one after the other to explain a better thing. Actually, this image is taken from this link, which is the same architecture, with same type of architecture which we use. So the first, what happens is it takes an image and it is transformed into 224 into 224 into 3 size tensor. So here there are various transforms that will be applied on it and is formed into a tensor. This tensor is given as an input to our convolutional neural network, which provides an embedded image vector. This image vector will have the extracted features of this image. Then on taking that one as an input, it tries to predict the caption for that image. You can see it first gave A, then after A it got man, and at last it is turned out to a man holding a slice of pizza. We use LSTM to avoid problems like vanishing gradient, because of, as we used a large data set, we thought we should go for LSTMs. And you can see here let me move on to the next slide. From here onwards, I'll explain how we designed our CNN. We use transfer learning technique to create this CNN. We used a pre-trained network, which is ResNet 50 network. The reason why we used pre-trained network is this worked very well on ImageNet dataset, and these are the winners of ImageNet competitions. As they have better accuracy, they will have better feature extractions. So we use the transfer learning technique to modify this pre-trained ResNet 50 network. We removed the last layer, which is having around, which will be giving an output of 1000 elements tensor. I mean, the size of output is 1000. So then we added a new layer, a new fully connected layer in place of that, and we also turned off the required grad parameter for all these things to false, and these will not be participating in the training process. Only the last one will be participating in the training process. This will have an output size which is equal to the output embedding size, which the output size of this net fully connected layer is equal to the embedding size we used in the recurrent neural network, because the output of this one will be given as an input to that. After that, this whole thing makes our CNN. From here onwards, we represent this one as this one. So this one is used here, and whenever any image is given as an input, the whole flow goes on. This completes our architecture of CNN RNN model. Moving on to the training phase, we used MS COCO dataset. This dataset is of size around 25 GB, and it also has around 160K, or it is of size 25 GB. And we use batch normalization for achieving better training and for using a large batch size and such kind of things. We used batch normalization to get better results. We used Adam as an optimizer for this. Optimizer is nothing but which drives the training process in such a way to reduce the loss. And moving on, we use cross entropy loss as our loss function. After tuning hyperparameters like the embedding size, batch size, and such kind of parameters, we trained for 23 epochs for around 70 hours on GTX 1060, which is a GPU from NVIDIA. We limited to this one because of our resource constraints. After training for this long period, here are our results. The first one is, this is the one which is given as an input to the network, and it shows this one as an output, a sandwich with meat and cheese on a toasted bread. I hope this is pretty much similar to what is inside the image. You can also see a herd of sheep grazing on a lush green hillside, a kitchen with stove and sink and microwave tiles, a clock tower with a clock on the side of it, a man playing tennis on a court, a large elephant standing in the field of grass, a table with a plate of food and drink. And there are things which we need to improve. Even if you see this image, a woman is playing tennis, but the caption is a man holding a tennis racket on a tennis court. And moving on to this image, a dog is looking at a reflection in a mirror, but here we have reflection and dog, but we have two dogs here. And even a baseball player is getting ready to hit a ball, but the biggest thing is he already hit the ball. He is on his run to. So next steps. So after creating our CNN RNN model, we did the three things mentioned on the screen. First one is we created a web interface. We created this to test the images, and it will be having an upload button. After uploading the image, the caption for that image will be provided. Not only a single one, there will be 5 captions will be generated in that, and I will be showing that after completion of these slides. And we created an API using Flask to provide captions to the image. The reason why we created this is to help a lot of web developers to automate the process of automate the process of adding alternative text to an image, because there will be a lot of situations where the web developer cannot look into the images and give an alternative text for that. So to automate that process, we created this API. And next and most important thing in our work is Chrome extension. We created a Chrome extension called Add Alt Text, AAT. This is created to provide real-time image captioning to websites. For example, if at all any visually impaired person wants to know what is inside an image and that image does not have a better alternative text, using this Chrome extension they can know what is inside the image. So this is very much useful to the people who use text readers or who are visually impaired. On clicking a single extension, they are going to know what is inside that image. How our Flask application works. So this will be the flow of our API or Flask API. So whenever an image is given to it, it will be transformed into 224 into 3. Here I forgot to mention 3, and that will be a 224 into 3 vector and image. That image will be converted as a tensor. After conversion of that will be given as an input to the CNN, and it generates this array of this tensor as an output. So the reason behind these numbers is during the training process we collected all the words in the data set, and we given different numbers for different words in the data set. And whenever any caption is given to the training phase, actually each and every word will be converted into their respective numbers, and they will be mapped. That will be given as an input to the CNN RNN model. So the output will be also of the same kind. Here 0 stands for start symbol and 1 stands for end symbol, and remaining numbers are nothing but they may refer to something like the or a bread or such kind of things. And this tensor will be moved to a function called clean and generate captions. This will clean this tensor and create this type of output. This is the caption that is generated for this image. So the API provides two kind of services. One is if at all the client sends any image to the image captioning API as a request, it will generate image caption and send it as a response. On the other hand, if at all they send the URL as request to the API, because the reason behind this URL is a lot of images on the web will be having a lot of it is very much easy to work with URLs, and automating this process, mainly this is the process which we used in our Chrome extension, because it reduces a lot of time of saving the image and such kind of things, and it increases the speed. So this is one more thing. If at all you send the image URL, it is going to respond with the image caption. And finally, our Chrome extension. How AAT Chrome extension works. This is the icon or logo of our extension. So this is the workflow. Whenever we intentionally made it as on-click things because to better demonstrate the things, but the whole process can be done without clicking anywhere, and after automated after the opening, after the website loading. So whenever this extension got clicked, this is going to extract all the image objects in the website. So for example, if at all there are 10 images, all those 10 images objects will be collected here, and this is a for each loop. For each loop, nothing but the single function will be applied on all the elements. So for every image object, that will be sent as a request to this one. Actually, the image.src value, which will be having the URL, will be sent to the image captioning API. So after sending that URL as a request to this API, this will provide a caption as response to the client, to the browser. Then this Chrome extension will add that caption in place of ALT attribute of respective images, and this loop will be continued until all the images got the captions. So once all the elements are done, it is going to stop. Conclusion. So we developed the CNN RNN model to generate caption in human spoken language to the given image. This is one of the work we tried, and the reason behind this is already mentioned, and we want to automate the task of image captioning. Then we proposed an automated way to increase web accessibility to address a large amount of image data that is being created every day. We proposed different methods to achieve this. They are using our API Chrome extension, and it can also be easily implemented in different other platforms. So using our things, we think we can help a lot of visually impaired people on the globe to know what is there inside the images, and this can also be extended to, as I already mentioned in the other place, like creation of an Android application that can read the whole scene around it. So with this, we want to increase accessibility in the web and want to help a lot of people on the globe. References. These are the two papers which we mainly focused on and we mainly depended on. We used the best practices from these papers and we reproduced the CNN RNN model. We also taken help of this accessibility link, which is from W3 Consortium, which is the one who started the accessibility on web, which proposed it. In the next part, I'll be explaining how our three applications, the web interface, API and Chrome extension are going to work. So after this slide, I'll be moving on to the implementation part, where I'll be showing the real-time implementation of our models and our applications. Welcome to our web interface. This is the web interface we created to test what is happening, to know how are the captions are generated in this, to know how are the captions are generated for a given image. In this we have an upload button, So let's click on the file. You can select any image here. For example, if at all I select this one and click on upload, you can see a tennis player reaching to hit a ball. A man is playing tennis on a tennis court. These are the things. So we created 5 different captions for this. We simply iterate the process of generating captions 5 times to know how the captions are generated at different iterations. So if at all you select any other new thing, for example this one, here you can see a train moving down the tracks by a station. Let's move on to something interesting. So for example, you take this one as input. It is taking much time only because of generating 5 different captions 5 different times. So here you can see a man is riding a skateboard on a ramp. Man is riding skateboard on a sidewalk, standing on a skateboard. These kind of captions you got. You can iterate this step for different things. If at all I use this for this giraffe image, a giraffe standing in the middle of a field, standing next to a tree, such kind of captions we got. If at all I move on to the bear this time, black bear is walking along a path, walking on a grassy field. So if you take this image, you can see a clock tower with a white type background, a large clock tower with a massive clock on its face. This way, our application provide different images for different captions for different images. So let's move on to our web extension part.
Photos. Heading 1.
Welcome to our Chrome extension part. So in this part, I'll be introducing you to text readers. These are the tools that are used by a lot of visually impaired people to learn, to know what is in the website. Here we are using an extension called ChromeVox, which is made by a team of Google. It is a kind of text reader, works on the Chrome. If you can see, first of all, let me reload the page for you.
Heading 1.
So it tries to explain what is.
This is a testing page to demonstrate the automatic image captioning using Chrome extension to increase the accessibility for text reader users.
As you can see, it is reading out what is inside the text of the website. You can also, they use tab key to move throughout the website. For example, if at all I click on tab,
IMG4 image, IMG7 image.
Now we made this website for testing purpose, and we intentionally did not added ALT attribute to this website, to any of the image in this website.
IMG6 image,
Behind, and you
IMG9 image.
How the ChromeVox is reading out about the image. If at all any website is in this type, it really hurts the feelings of the user, and they really feel bad about it. So now move on to our extension. First of all, let me click on this extension to activate the process. And let's move on to the first.
Heading 1. This is a testing page to demonstrate the automatic image captioning using Chrome extension to increase the accessibility for text reader users. A man sitting in front of a laptop computer.
Now you can find the difference between our previous step and this step. instead of simply saying it is something image, simply saying the image file name, it is explaining what is inside the image. This is done by the work of this extension.
A man is surfing on a surfboard. A double-decker bus is parked on the side of the street. A pizza with cheese and spinach on top of a white plate.
So now you can see the experience is far better as compared to our previous experience. Now, to know how is it working here,
Web view.
let me start the
Unknown. Console panel.
to clear
Tab panel.
console. Let me reload the page.
Photos for testing. IMG9 image.
So you can see add alt text extension started already, but
IMG4 image.
text for these things we intentionally made this to explain how it is before clicking on extension and after clicking on extension, but we can simply automate the process only during the starting of this extension to add alternate text automatically after loading the page. But to demonstrate the things, we made it in this way. So after clicking on this extension, see what's happening. Got the command start adding alt text. Initializing the process, request successfully submitted, and these are the responses we got from our API that we created previously. Now if you see what is in this image,
A man riding a wave on a surfboard. A red double-decker bus driving down a street. A pizza with cheese and pepperoni on a wooden platter. A man sitting in front of a laptop computer.
so you can really understand what is the difference between previous things and these things, and you can appreciate what is the work of this Chrome extension. In this way, it really helps a lot of people to know what is inside the image. For example, any website of this kind is to be used by any visually impaired person. They can simply use our extension and we can directly automate the task of adding these captions, and if at all they required, we can also add some shortcut keys to initialize the process. In this way, alternative text can be automatically added using our CNN RNN model and our Chrome extension. Thank you all for joining me in this project walkthrough. Thanks to all the team members and the project guide who really helped us a lot. And thanks to all my team members. Without their support, we will not be in this stage. And thanks to each and everyone who helped us and who mentored us in a way to achieve our goals. Thank you all for joining this project walkthrough. Thank you.